Right. My name is Jose Quesada. I'm the director of the Science Retreat, and I'm here to talk about machine learning in the Spark slash Scala world. Originally, David was going to do this talk, but he got sick, so I'm replacing him. I've changed the talk a little bit from my experience attending Scala Days New York and from conversations in the corridor here in Berlin. So my gut feeling after talking to several people here is that there is not that much machine learning going on in this particular audience. So can you raise your hand if you have deployed a machine learning model? Okay, no, there is some, okay. So we are doing better than New York, definitely. So it was like 25% of the room raised his hand, and in New York, I would guess it will be 10% or less. Right. Okay, so I'm going to start very slowly with a definition of machine learning. So there are plenty of definitions. It's not like one of them is better than the others. This one I particularly like. So you're going to build things that learn. So you have to encode what the machine is going to do. The machine is going to learn that. And that's why it has this name of machine learning, right? Right, so why this talk? Well, I'm going to go out of a limb here and say that in 5 years' time, we are all going to be deploying machine learning models. So today, in 2016, 25% of the room raises his hand. In 5 years' time, I'm betting that the entire room will have raised their hand, and this is a consequence of how easy it is to build products with machine learning nowadays. So if you were around back in the 70s, I guess, when relational databases became mainstream, there was a time there that nobody knew what was going to happen, but then after that window ended, SQL was everywhere, and everybody knew what relational databases were. Same thing for the web in the 90s. Oh, HTTP and HTML and so on. For a while, it was new and shiny, and then everybody was doing it, right? So I suspect that we are in the same point right now with machine learning. So it's becoming mainstream in a good way and in a bad way, you will see. So the alternative to this not happening is pretty bad, because that means that machine learning will stay a dark art that only a few practitioners know, and they tell their students in a corner of some university, and that's not good for anybody, right? So this is how I came up with this prediction of 5 years. In the 90s, the typical VC pitch will be, well, this is like blah, but on the web, and this will work. In the notice, it was, well, this is like X, but social. In the teens, this is like X, but on mobile. And in 2016, if you go to a VC, very likely you're going to hear, this is like X, but with machine learning. Right, so you may have found this on Twitter floating around, that software is eating the world, that many industries want to become software, industries that you will never imagine. So the last 2 days, there was an IoT conference in this same building, and you could see car manufacturers there, like hardcore manufacturers of like physical things, saying, we want to become a software company. So that's the software is eating the world part of it. But of course, that's only the beginning. So some people say that machine learning is going to be on top of that and is going to produce more value. So then machine learning is eating software. And the perfect example, the follow-up example, is self-driving cars, right? So this is why manufacturers, people who are making their living building physical things, want to become software companies. Right. And the really interesting thing is that this is not happening in the US only. So you know Andrew Ng? So he's the founder of Coursera. He was a Stanford professor for a long time. He's one of the most prominent machine learning heads out there. He went to Baidu in China, and I guess this is a first that people of that caliber are moving away from the US. It used to be the other way, right? And he's building all kind of crazy stuff for Baidu. He said in this Spark Summit talk that he's building hundreds of projects where the goal is not profit, it's not making money, it's getting more data. Because any one of these companies have a big investment in machine learning, but they are only 1 year ahead of their competitors, and that's not defensible. But having data that nobody else has, it's very much a barrier of entry, and this is what they are trying to build. So people who understand that are surprisingly not only Google, Facebook, and Amazon. So there are plenty of people all over the world understanding this, and surprisingly, even car manufacturers seems to be starting to understand this. So there is more value in the data that you collect than in the physical thing that you produce. For example, this Fitbit thing that I'm wearing is probably 50 euro, but the data that it collects is probably worth more than 50 euro for more than one company, not only the makers of this. Right, so let me show you an example of what's possible nowadays with machine learning. So this is an example of image recognition in video, and it's getting to a point that recognizing objects in images is becoming a solved problem. So that was not possible in 2014 or even 2015. This is actually a toy implementation of a neural net that recognizes objects. So you can see up there, it's from very often, but it's kind of amazing that it can tell you what it sees. So to simplify this, computers can see now, right? And it will be wrong plenty of times. This is actually implemented in JavaScript, I think. It's a very toy-like problem. And this guy is walking around the street with a laptop, pointing the laptop at things. So this is running on a laptop. A real production machine learning system will be running on plenty of GPUs on servers, right? And it will be doing much better than this. But this is where the state of the art is right now. And this is images. In text, you can find a challenge that just ended 2 weeks ago, where you could upload a picture, and then the challenge was to answer any question about things that were in the picture. Like how many sheep are in this picture? And the machine can do a pretty decent job at answering any question about anything in a picture. So this is not the type of things that we were used to do 5 years ago. So if you tell me 5 years ago that this was going to happen, I will tell you that you're crazy. Right. Right. So data science retreat. This is a company here in Berlin that specializes in training people that want to switch career and go into data science, machine learning, and so on. We've been doing this for 3 years. And the way we operate is to get the best people we can to teach every topic. They teach only 2 days or so. They go very deep into one topic, and we bring as many of those as we can. The people who attend the retreat are also pretty decent when they come. We interview about 200 people per batch and accept 5% of them, like 5 to 10 guys. We try to get people who can develop products, so they can see a need in the market and they can put together a product. And they do that in portfolio projects. And then they go in front of companies and they get hired and go do interesting things for companies. Why do people do this? Because there are plenty of online materials out there if you want to learn machine learning, right? I think there is something. So this is the histogram of ability in data science. So there are plenty of people that can fit a random forest. That's not a problem. Everybody has done a MOOC that taught you how to fit a random forest. But doing the typical 10x totally spectacular improvement that would make serious money to a company. That's not so easy, and there is nothing in between. And I think people come to the SR to jump from one side to the other. That's just my guess. This is an example of a smile recognition system that a participant built. So it could look at many people in the room, but this is just one face. This was 2014, so when deep nets started becoming popular. And the feedback that he got when he presented this in demo day from the companies who were trying to hire them was like, why did you want a job? Why don't you just go and create a company with this, right? So he went and did, and now he's doing a smile recognition with fake smiles. So this is now pretty known technology. Cameras do this, catching images that are smiling and so on. But in 2014, that was kind of spectacular still. Right. So people who come are happy. Companies who hire them are happy. So everything is working. So why am I talking about this? And why is DSR actually doing any of this? Well, Lightband has a partnership with IBM. So IBM is behind this big data university. And they reached to us to produce online materials to train people who want to do machine learning in Scala. And at that point, there was nothing out there on the web for that particular problem. And we've built about 25 videos already. We are going to build 75 total. And we'll talk more about those videos. But now there is a pretty serious body of material out there if you want to do machine learning on Scala with Spark. The interesting thing is that people who do Spark, they do plenty of Python, surprisingly, although it's pretty hard to do things from Python. So I don't have to convince you, if you're in this room, that Scala is a very good language to do anything with Spark, right? But the world out there is different. So since I have to interview many people and go to conferences, and so I meet all kind of personas that want to do this kind of thing. So let's go one by one. So I made them really like stick figures because I want you to make sure that these are totally invented characters. This is a caricature. So what I'm going to say next is not at all something that is out there. So it's just a caricature, right? So there are machine learners out there who are not engineers, and they build things that don't go into production ever. They tend to be pissed about that because nobody wants to spend 6 months building a model that never goes into production. But the tooling that they have is partly responsible for that. So they build things in scripting languages, often on notebooks. They don't care too much about parallelization. They just want to make it work in one machine, where the only bottleneck is the memory on that machine, and then you can buy a big machine. And then it's somebody else's problem to deploy the model, right? And that's not a good strategy overall. So I meet plenty of these people, and they are extremely capable. They do super interesting things, but they're limited by their engineering ability, right? So yeah, R is pretty popular in that camp, although it's kind of slowing down. So this is a totally subjective graph of popularity of programming languages in that camp. Scala is getting a lot of traction there, but still there is a long way to go until it becomes mainstream, partly because Scala is damn hard to learn. More so if you come from an environment that is not at all about engineering. I did a talk in Python in the PyData conference here in Berlin a couple of weeks ago, basically telling people that they are better off doing Spark in Scala, and that was a room full of Python guys. I was expecting to be crucified upside down, but they actually agreed. So I'm not surprised if this thing next year is going to be somewhere here, right? Okay, so backend guys. So they have a big investment in Kratt. So basically they are running some website that got out of hand, but it started with something innocent like a Ruby on Rails app that just grew and grew. And they know their stuff really well. They definitely, they are engineers, but they are not great outside the monolithic framework that they invested in, right? So these guys are seeing the writing on the wall, and they are trying to do something about it. It's not surprising to find people doing Ruby in a functional way with kind of a flavor for the kind of things that you normally do in Scala, but it's just not a good fit. Okay, so this animal I actually encounter less often, but you may have different a different sample. So the things that they end up doing is kind of menial work, and they are kind of okay with it because they are surprisingly comfortable living in that kind of culture. They tend to like certifications and design patterns. And the one advantage about this group is that they are easy to find. And what I see often is people who need data engineers or Scala engineers, basically, to just hire these people, set them alone in a room with a bunch of books and hope that they will somehow pick it up. Right, and this animal I think I only encounter when I come to this type of conferences. So this person is basically impossible to hire. They are all working for Lightband or on some gigantic company that pays them very well. They definitely know all these new things that you can do to make scalable, resilient applications and so on, and they are doing them already. But the interesting thing about them is that, at least when I talk to them, they are not doing any machine learning. And some of them do want to do more, but they feel that there is a big gap between what they are doing and what they should be doing to do real production machine learning systems. So I'm going to talk a little bit about why this is here. So we have our personas, and for the rest of the conversation, I think we can ignore the two middle ones. Oh, actually, I think I skipped one slide, but so the two middle ones are going to have problems going in this direction or in this direction. So the interesting thing is that these two things are extremely hot, delivering a lot of value, but it's very rare to find people who can do both. And I think we do need those people, because when you make mixed teams, it's really hard to communicate. So there is a mindset that is very strong here about what is worth doing and what is not worth doing, and it's definitely not the same mindset as in this side. So there are all kind of communication problems. So the best thing would be to have a single person that can combine these two groups. So in data science retreat, we are trying to get people in that direction, but it's really hard because this part alone takes quite a bit of effort. Right, and the interesting thing is that when any of these two sides look at what the other one is doing, they go like this, right? So they really don't understand why the other group values what they are doing so much. But there is something that has happened recently that has changed that quite a bit. And that something is Spark. So Spark is built by people who understand this group, and surprisingly, they understand this group too. So what Spark is doing is really keeping a delicate balance between these two groups, and you will see next why it's that delicate balance. It's trying to make these people happy and look at the things that they like, right? And these people happy. And these two things are really not the same at all, right? So just to give you an example, at some point, like 2 years ago or so, 1.5 years ago, I was in London at a training where Databricks announced the DataFrame. And you could see in the room 2 groups going in completely different emotional directions. So there were all the scripting guys going like, hey, this is what we have, data frames in Python and R, right? And all the Scala guys going like, oh, it's not type safe, you know. So the thing that they did really well is to find a balance again. So for a while, DataFrame was the new thing that everybody wanted to do. It was really fast because it was doing all kind of optimizations within the SQL engine and so on. So doing RDDs felt kind of wrong, although RDDs are typed and definitely have their advantages. The ecosystem on machine learning and so on started building on DataFrame and ignoring RDDs. But at some point, DataSet appeared. And DataSet has the same API as DataFrame, but has the advantages of RDDs. It has types. So now both groups are happy. And that's really a feat, because they could not be more different. Right. So then what I envision happening is that both of these communities are going to start converging. They are both sides are going to start trying to learn from what the others are doing and why they find it valuable. So, is Dean in the room? Well, Dean Wampler has been saying for now 3 years or so that Spark and Scala is going to become the de facto machine learning language. And I keep hearing this from other people too. So if he's right, what we're going to find is a huge avalanche of people coming to Scala who have no real background in engineering, and they have to pick it up somehow. So Martin Odersky said that about 50% of the newcomers to this community are coming because of Spark. So that could be part of the reason. Right, so then there's going to be a little bit of a problem with onboarding. So we're going to have situations similar to the refugee crisis. So you will have plenty of people in forums and Stack Overflow asking things that you may think like, well, this doesn't make any sense. And there are many of these people who want to come into the camp of, well, reactive everything and Spark on Scala and so on. This is going to be interesting, how we actually assimilate the influx, because I can see it coming. So there was a room as big as this one in the Python PyData conference, and they were all nodding when I was saying, like, well, if you want to do Spark, just do it in Scala. So these guys are coming. Right, so going in this direction is, I think, easier, although none of the directions is really easy. But it's easier because of this partnership, Lightband, Big Data University, and well, the Science Retreat, making these videos to make sure that people can go from this to this. So the videos assume that you know what you're doing. So all these things are not explained, so nobody's going to teach you what the gradient boosting tree is, but it's going to show you how to run one on a Spark from Scala. And they are online, you can check them already. The 50 new ones that are coming in July 15th are actually pretty advanced, and it's really getting challenging to produce them, but I think the results are going to be very useful. So if you have 75 videos, you can definitely make this transition. Right, the other transition though is, well, just before I move on, this is Twitter. Twitter had this problem. So they had Scala written by people who wished it was Ruby, Scala written by people who wished it was Java, Scala written by people who wished it was Haskell, right? So this is going to happen somehow with all the machine learners coming to the other side. So can we do, I don't have a good solution for this, but can we do anything better than just hire a person and drop him in a corner of the room and just cover him with O'Reilly books and hope that he's going to pick up all the engineering that he's missing? I don't know. I wish I knew. Right. So the other direction is a little bit harder because there are no 25 videos that teach you this. There are MOOCs, though. MOOCs are pretty good. Everybody I interview has done plenty of MOOCs, My impression is that they don't find them so effective. So after doing a bunch of MOOCs, people kind of can talk machine learning, but cannot do machine learning. I don't know why that is. Because when I watch the videos myself, they're pretty awesome. So how is this going to happen? I don't know, but I have some pointers. So there is something about the mindset of an engineer that doesn't fit in this world. So I'm going to try to cover the most obvious ones to me. So the first thing is that there is no spec. By spec, I mean a list of things that you have to fulfill to declare your app successful. For example, something will be like, well, this thing has to serve 10,000 connections per second. Fine, so then go and find the technology that can provide that, right? In the world of machine learning, that doesn't work. Somebody could come to you and say, well, we have to classify dogs and cats, and the classification performance has to be 95%. And you can only say, like, I don't know if I can do this. Well, for that example, it's kind of becoming easier to say yes. But anything else that somebody asks you to predict, oh, let's just get the data scientists to predict whether we're going to do well in Asia. And we don't have any data about ourselves in Asia. Well, they cannot do anything. So there are so many things that you cannot say yes to when you are in data science. And that doesn't happen so often in data engineering or in engineering in general. So that's the science part of it. So there are plenty of things that can fail miserably, and you have to learn to live with it. And basically educate managers to understand that this is the way it works in this world. Another very interesting thing about machine learning is that when something doesn't work, you don't know how long it's going to take you to fix it or when it's going to work at all. So imagine that you apply your model and you got whatever, 85% performance. Can you get to 90 in 1 week, in 1 month, in 1 year? You don't know. And the obvious stakeholder question is, okay, so how long do you need to get this to 95%? And the only answer to this is, I don't know. This is something that an engineer doesn't like and cannot afford, basically. So estimations suck all over the place in engineering, but at least you have kind of some boundaries. In data science, you can never say, I'm going to get to 95%, because that may be impossible. And even when you have a lot of experience, you can still not predict how well an algorithm is going to perform in a particular data set. Right, so I wanted to compare how it feels to do machine learning on Spark from Scala compared to other things in terms of features and just niceties and so on. So one thing that is pretty shocking when you go into this world is that there isn't that much built already. So this is the Python world for deep learning. There are literally tens of libraries, and they kind of go up and down in popularity, but there is always something to choose from. In Scala Spark, there is only deep learning for J. Where is it? It's not even very high, but well, here. These guys are really doing very well. They're doing something very valuable. And if you go, tomorrow there is a talk by Andy Petrella, who may be in the room, about how to do deep nets on Spark, or at least on Scala. But look at the choices that you have outside of the JVM, sort of, right? This is something that you miss when you go into the other side. And that's the same for everything, for natural language processing libraries, for sparse matrix multiplication libraries, anything you want, there is either nothing or one choice. And in outside, there is like plenty of choices. Right, so one thing that is clear by now is that Hadoop MapReduce is not very interesting. There are people still doing it for ETL and so on, but it's not exactly a best of class solution anymore. So Spark has killed that completely. But what I see here is that people are going into Spark just to to do something that they were doing already with MapReduce, but doing it easier. And that's not the point of Spark. The point of Spark is that you can do so many other things that were completely ridiculous before, like machine learning, graph analysis, streams, all that stuff was completely impossible before. And what I see people doing is just to convert the MapReduce jobs to Spark because it runs faster. So that's totally missing the point. Right, so Spark was designed by people who really knew what they were doing, both in the engineering side and in the machine learning side, so that shows. And there's plenty of stuff that is already implemented. And there it's very easy to go to production because you are already basically in the same platform that is going to be in production. And people are building on top of it, so it's not only these two libraries. This was MLlib was based on RDDs. Spark.ml came about the time DataFrames came. This is IBM putting out a library that looks kind of like a DSL, so it's pretty easy to use for people who are used to scripting languages and so on. And this Keystone ML is actually from AmpLab as well, but has other advantages. It's kind of alpha, so nobody's talking about it yet. But so it's starting to happen that there is more choice. But like a few months ago, even a year ago, there was just Spark.ml, and before that, only MLlib. So there are some basic ideas that are very nice, very general. So one thing that you notice when you go to the other side is that people build things that are extendable and that are like loosely coupled and so on. So the code quality is much higher than in the machine learning world. So these are basic pieces to build. So the main advantage that I've noticed going to Spark from Scala is hyperparameter tuning. So instead of having to use only one machine that runs for weeks to get the best parameters for your model, now you can just go to Amazon and get 100 boxes and just run it in a day or in half a day. And that's really, really a huge jump in quality of life. So nobody likes to wait for a week to get the results. And when you have to, you feel like you're not making progress. So it's kind of boring. And you get less spectacular results because you try less, because it's just more boring. And this comes for free with Spark. So that's a huge win right there. Now, the elephant in the room is that you spend a lot of time cleaning data. And that's actually pretty nice in Spark. So in Spark, doing ETL, it's comfortable, and you're doing it from the same environment that you are doing your machine learning. That's pretty awesome. And just the last thing, but it's kind of important too, is that the models run faster. So if you have a parallelized version of whatever, linear SVM, well, it just runs faster than in one machine. So this is another free win, basically. So the gains are pretty obvious, and everybody will like to have this. So this is why I'm expecting some crazy migration from all these Python machine learning guys to Spark and Scala, basically. Right. So one thing that doesn't happen very much is people sharing components. And maybe because Spark moves so quickly, people push things, ask for like request to merge the code with the code base of Spark, and people just don't have the capacity to merge the pull requests, and they just linger there and die because Spark has now moved, and the pull request will be impossible to merge anymore. This is just a consequence of moving so fast, right? Right. This is pretty interesting. Catching errors is far better with Scala on Spark. And now with datasets, it's going to be even better. So datasets are coming in Spark 2.0. And that's something that is Scala only. So that's one more reason for the Python guys to say, hey, we should consider Scala. Right. So since we were teaching mostly in Python and R for like the first 2 years, and the last year we've done plenty of Scala, we had to convert many tasks. And we can tell you the experience that we had doing that. So this task was very heavy on data pre-processing. It's a task where you have to predict if an university group is going to get a grant or not. It's from Kaggle. It's super dirty, and it's not big or interesting in any way other than it's super nasty. And then you have to do a lot of feature engineering. This task is the one I mentioned before, where you upload a picture and then the system has to answer any question about the picture. And the state of the art is about 70% right now. Pretty cool. This is still ongoing. Oops. This is still ongoing, but it doesn't look too bad. So I think the move to Scala has been positive there. This example is sort of a competitor to Buffer that can recommend you who to follow, not only when to tweet, but when to tweet for some badass guy that you want to get noticed by to actually see you. So this has a lot of graph analysis. So it's GraphX. I was trying to use the new graph frames, but it was not great. So I'll tell you a little bit about that later. So things that are a little bit painful is indexing categorical variables. You have to do the indexing by hand, sort of, which is not nice at all. And this feature assembler thing is also kind of nasty. So everything that is a feature has to be in a vector format. So it's very not pretty for humans. So for pipelines, the approach is pretty much the same that people are used to in the Python world, in scikit-learn. Basically, they clone the pipelines from scikit-learn, and that's a very smart move. For text processing, natural language processing, there is a pretty much one-to-one mapping between anything that you want to do with scikit-learn and what you can do already with NLP in Scala Spark. So that's very nice. The GraphX stuff was a little bit of a pain to get it to work, mostly because we tried with graph frames first, and that was a bad choice. So graph frames are not ready for prime time. And GraphX, I hear that it's not very maintained, that it may not get as much attention as it should. It's a pity because it's actually very useful to have a graph data structure that is native to the entire platform. Right, things we liked, well, the architecture is definitely very nice. The code quality is better than what you find outside. Type safety, of course. The way pipelines and models are the same thing is also very elegant. The way you pass parameters is pretty nice. Well, it's very easy to parallelize ETL and do grid search. So grid search is kind of the biggest win. So if you have to find the best parameter for your model, just moving to Spark is a huge win already. Disappointments, not so many, but the feature indexing is kind of tedious. Sorry. That should not happen. Right. So there are some silly little problems like the depth of trees that is limited to 30, which is kind of stupid. Visualization and data exploration is not there. You have to go to D3 or something else. And well, deep learning is not really very advanced, but these guys are moving very fast. So just to conclude, a reminder that there are all these videos. You can access them through this URL as well. And if you have the time, just go through them because it's really the easiest way to get into this. And well, thank you for your attention. And if you want to talk more, we are at the booth outside shared with Lightman. So thank you.